Welcome to the deep dive. So today we're tackling, well, maybe the biggest question there is, based on your sources, how does it all end? I mean, we talk about the universe's beginning, that 13.8 billion year story, light, energy, matter, us. But, if all stories have an end, what about the story of everything? Is it like a huge fiery finale or just a cold fade to black? Let's get into it.
Yeah, it's fascinating. And what the sources really point to is that the answer hinges on one thing, mostly. This mysterious force we call dark energy.
Right, the stuff we can't actually see.
Exactly. Can't see it, can't touch it, but we see its effects. It's pushing space apart and actually accelerating that push.
So the whole fate of everything rests on this invisible energy.
Pretty much. Its precise nature, how it behaves over time, that dictates the end game. And based on current theories, there seem to be, well, three main possibilities we should explore.
Okay, three ways it could go. So diving into your first set of sources, the front runner seems to be something called the Big Freeze or heat death. Sounds chilly.
It does, yeah. It's quite a stark picture. This scenario assumes dark energy is like a constant, a cosmological constant, Einstein called it. Just this persistent, gentle push forever.
Gentle but relentless.
Exactly. So over trillions, and I mean trillions of years, galaxies get pushed further and further apart.
To the point where you couldn't see the others anymore.
Right. They cross a kind of cosmic horizon. Their light just can't reach us ever again. Imagine looking up the night sky would be almost totally black, just the stars in our own local merged galaxy.
But even those stars, they don't burn forever, right?
No, absolutely not. They run out of fuel, they die, they leave behind remnants, white dwarfs, neutron stars, black holes, cold, dark cinders, really.
The universe becomes this vast, dark graveyard.
Essentially, yes, for an incredibly long time. But then, over even more unimaginable timescales, even those remnants might decay. Black holes are thought to evaporate through Hawking radiation.
Slowly leaking away.
Very slowly. And maybe even protons, the very building blocks of atoms, decay. Eventually, all matter could just dissolve into a thin, featureless soup.
Wow.
Yeah. The universe reaches maximum entropy, perfect equilibrium, same temperature everywhere, incredibly close to absolute zero. No heat flow, no change, no life, no thought. Just cold, empty, eternal quiet.
Okay. That's profoundly bleak.
Yeah.
A cold, quiet end. But you mentioned that depends on dark energy being constant. What if it's not? What if our understanding is wrong?
Yeah.
Your sources mention a much more violent end.
They absolutely do. This is the big rip scenario. And it happens if dark energy isn't constant, but actually gets stronger over time.
Stronger, so the expansion speeds up even more.
Dramatically more. So much that it eventually overcomes gravity, even on smaller scales. First, it pulls apart the big structures, galaxy clusters ripped apart, then the galaxies themselves.
Just flung into the void.
Yeah. Stars torn from their galactic homes. But it doesn't stop there. As the end gets closer, the force gets stronger still. It would overcome the gravity holding our solar system together.
So planets torn away from the sun.
Exactly. Then the forces holding planets and stars themselves together fail. The Earth would be torn apart.
Whoa.
And it keeps going. In the final moments, this phantom energy, as it's sometimes called, becomes stronger than the electromagnetic force holding molecules together, than the nuclear forces holding atoms together.
So it rips apart everything. Buildings, trees, us, down to the atom.
Down to the fundamental particles. In the last tiny fraction of a second, the expansion becomes infinite. It literally tears the fabric of space-time itself apart. Not a cold fade, but a sudden, violent, universal shredding.
That's terrifying. Okay, big freeze, big rip. Your sources also mentioned a third way, almost the reverse. The big crunch.
That's right. This is the third main possibility. It relies on dark energy doing the opposite. Maybe it weakens over time, or even reverses, becoming attractive instead of repulsive.
So gravity would win out in the end.
Gravity takes back control, yes. The expansion slows, it stops, and then it reverses. Everything starts coming back together.
Galaxies rushing towards each other instead of away.
Yes. Over billions of years, they'd merge in these huge, fiery collisions. The whole universe would heat up. The background radiation would get hotter and hotter until the sky itself glows brighter than a star.
And everything just collapses back in.
Ultimately, yes. Everything gets squeezed closer and closer. Stars dissolve, black holes merge. The universe becomes this incredibly hot, incredibly dense plasma.
Crushed back into, like the state it was in before the Big Bang?
Essentially, yes. Back into a singularity, an infinitely hot, infinitely dense point. Now, this sounds like an end, but it holds this well, this really tantalizing possibility.
Which is?
That the Big Crunch might not be the final end, it could be the trigger for another Big Bang, a cosmic rebirth.
A cyclical universe. Bang. Expansion, contraction, crunch, bang. Again and again.
It's a possibility some models allow for. A universe that endlessly renews itself.
So recapping the options here. We've got the big freeze, a slow, cold, lonely fade into nothingness. The big rip, a sudden, violent tearing apart of everything. Or the big crunch, a fiery collapse. Maybe, just maybe, leading to a new beginning.
That's the picture, yeah. And which path we're on. While it seems to be written in the nature of dark energy, this thing we're still struggling to understand.
It really makes you think.
It does. And maybe it leaves you with this thought. Could our universe truly be just one chapter in an eternal cycle? This grand rhythm of expansion and contraction, of cosmic death and rebirth.
That's quite a beautiful, almost hopeful possibility, isn't it, compared to the others?
It has a certain appeal, but honestly, the true nature of dark energy, and therefore our ultimate fate, is still one of the biggest mysteries out there. We're really just starting to get the clues.